Hello everyone. This lecture I am going to be presented the kinetics and reactor design in the subject of chemical reaction engineering. Basically, what is kinetics or reaction kinetics? Kinetics is a rate of any chemical reactions with the quantitative description how fast the chemical reaction proceeds, which affected by various parameters such as reaction temperature, pressure, type of catalyst used, reactors. So, what is reactors? Reactors is a device or vessel or a system in which the chemical reaction can be carried out. A device in which change in composition of matters occurs by chemical reactions. So, designing of this chemical reactor is to get a size parameters such as area, length, volume and etc. etc. What are chemical reaction? Reactions to be carried out in a chemical reactors. So, chemical reaction can be broadly classified into three categories. Based on the phase, it can be categorized into homogeneous reaction and heterogeneous reaction. Based on the reversibility, it can be broadly classified into reversibility and irreversibility, that is reversible reaction and irreversible reaction. Based upon the molecularity, this can be categorized into unimolecular reaction, bimolecular reaction and intermolecular reaction. So, chemical reaction and the rate of reaction. Consider a reversible reaction AA plus BP gives CC plus DD. So, in this reaction AA plus BB is a reactant species and the CC plus DD is a product species. The rate of this reaction is changing with respect to the rate of this reaction concentration changing with respect to the time. Based on the rate equation or rate law, this equation can be termed as R is equal to K of T and the function of concentration A and B. So, unit of this reaction, rate of reaction is mole per second meter cube. So, this reversible reaction AA plus BB is a reactant species. In reactant species, the rate can be denoted as RA of species reactant species A, which is always negative. Similarly, BB is a reactant species, is also a negative species, is also in negative, whereas the CC and DD of reaction rates are in positive. All species of reaction rates in certain reaction correlated through stoichiometric ratios, that is RA by A is equal to RB by B is equal to RC by C is equal to RD by D. This equation can be obtained experimentally by the reactant species. So, example of this species reaction is nitrogen oxide is oxidized to nitrogen dioxide according to the equation, according to the stoichiometric equation 2NO plus O2 gives 2NO2. If the rate of nitrogen dioxide was measured and found as 4, what would be the rate of other species? So, reaction based on the reaction model, it can be either power law model or complex rate model. For in this cases, this model is a complex rate model. The rate of this stoichiometric equation is termed as minus Rn2O is equal to Kn2O into concentration of N2O divided by 1 plus K dash CO2. Under specific reaction rate, the term K pre-exponential factor is the ratio of concentration per 1 minus n divided by time is equal to alpha plus beta. So, reactors what is mean by reactors? Reactors is a device or equipment or vessel in which the chemical reaction can be carried out. So these reactors can be classified as batch reactor and continuous reactor. What are batch reactors? Batch reactors is a reactor in which no flow of mass across the reactor's boundaries once the reaction have been charged. The schematic representation of batch reactor is shown in the slide. So mode of the operations of batch reactor mainly contains the cleaning. First we start the batch reactor. Cleaning is the primary stage. After cleaning, load the reactant species into the reactor and set the reaction temperature 0, T is equal to 0, and stop the reaction when the reaction proceeds, and unload the reactant species from the reactor. Next, the main characteristics of batch reactors is a closed system. Total mass of each batch is constant. Volume or density of each batches may varies with respect to reactions. The energy of every batch may varies with respect to reaction. The reaction time or residence times for elements of fluids is also constant. The operation of reactors is under unsteady state. Batch composition change with respect to reaction time. So what is continuous reactor? In continuous reactors, the flow is a main thing. Flow is a driving force in the continuous reactor. CSTR is a category of continuous reactor in which the reactor characterized by mixing, so that the property anywhere inside the reactor are exactly same as that of the exhaust stream. The model can be used for bed of catalytic reactor or fluidized bed reactor, slurry bubble column reactor and polymerization reactor. The schematic illustration of CSTR is given in this figure. Next, the main characteristics of CSTRs are flow through the vessel. Both input and out streams is continuously across the reactor boundaries. The system mass inside the reactor is main thing is constant. The volume or density of each batch may varies with respect to reaction. The energy of each batch may varies with respect to reactions proceeds. The residence time or reaction time of element of the fluids is also constant. These are all the common features of both batch and continuous reactors. Next, so PFR is a one classes of continuous reactor in which flow reactors can be characterized by the absence of mixing, in which the reaction is proceed with respect to the direction of flows and absence of variation normals to the direction of flow. This model can be used to model the tubular type reactors. Next, and main characteristics of PFR is same as like a CSTR. This next I am going to solve the problem. The reaction is explained A gives B is to carried out in a flow reactor. Species A enters the reactor at a molar flow rate of 0.4 moles per second. Using the data provided, calculate the volume necessary to achieve 80% conversion in CSTR, set the area, calculate the volume, set the area would correspond to the necessary volume, and fifth determination to determine the reactor in series, CSTR in series, 40% conversion is achieved in the first reactor. What is the volume of each of two reactor necessary to achieve 80% conversion. For 2 PFR in series, 40% conversion is achieved in first reactor. What is the volume of each of the 2 reactors necessary to achieve 80% overall conversion of the entering species A? These are the 6 questions. Based on this equation, we can solve these 6 evaluations. The data is given. X is a conversion minus RA is a reactant species, is given in the table. Next, so based on this reaction rate, we can calculate the reverse of minus RA. 1 by minus RA can be calculated by 1 minus RA. Okay, so next, this is the graph we can get by plotting the graph between conversion and minus 1 by RA. We can get the linear slope. From this slope, we can estimate the necessary volume changes, conversion, and etc. etc. And we have a questions. What are reaction rate? From this lecture, we must know about the reaction rate. What are reaction rate? What are all the factors affecting the reaction rate? Reaction rate is the speed of any chemical reaction, and temperature, pressure, reactor types can be affected by the reaction rate. Reaction kinetics is a study of reaction rate. And next question, classify the chemical reactors and compare batch and continuous reactor. What is the main differentiation between batch and continuous reactor? In batch reactor, we require flows, we require no flows, and continuous reactor we require continuous flows. Okay, thank you very much for your patience. Thank you.